Hi students, now we are going to explain how to find the root mean square velocity of the gas molecules. Now here for example I have considered a container. So inside this container there are so many molecules. Now all the molecules of the gas inside the container will not have the same velocity at any given temperature. So here the temperature is taken as T. At this temperature, the velocity of one molecule is taken as V1. Like that, the other molecules V2, V3, V4, V5, like that. Let us assume that the molecules have different velocities. Now, how to find the root mean square velocity, which is denoted by either V RMS or V square average, V square bar. Okay. Now for this, I will have to find out the squares of the velocities of the molecules. So V1 square, I will add this with the V2 square, which is the square of the velocity of the second molecule. Like that, I will add the squares of all these molecules. Say for example, there are totally n number of molecules may be there. Okay. So this is finally Vn square. There are n number of molecules I have taken. And I will divide this sum by the total number of molecules. Okay. So what I have taken in the numerator is the sum of the squares of the velocities of the molecules. In the denominator now I have taken the total number of molecules. So it is going to give some average value. Average value of what is given by this expression, the average of the squares of their velocities. So on the left hand side I have to write V square average. This bar indicates it is an average of the velocity square. Okay. And now I take this square root of this average. Square root of this average. Okay, I am going to take like this. So left hand side I have taken the square root of V square bar. So right hand side what it will become? This is equal to square root of V1 square plus V2 square plus V3 square up to Vn square divided by the total number of molecules, like this. So on both sides I have taken the square root, understand? And this square root of this average only is called as what? V RMS. So this only is called as the root mean square velocity. And in terms of temperature, in terms of pressure, volume and molecular mass, we can have so many expressions for this. So for solving the problems in the examination, what is required? This VRMS is given by formula. Okay. So what is that? First one is 3kT divided by small m. This is also equal to square root of 3 capital RT divided by capital M. These are the different expressions. Okay. So this is also equal to square root of 3 PV by capital M, because PV is equal to RT. Okay. So here small m is called the mass of one molecule. It is called molecular mass. Whereas capital M is called molar mass. If you take 1 mole, okay, Avogadro number of molecules will be there, isn't it? So the entire mass of 1 mole is capital M. And R is universal gas constant, K is Boltzmann constant, and T is the absolute temperature which has to be expressed in what? Kelvin scale. Okay. So these are all the different expressions. So one more expression also is there, my dear students. So you can see here PV by M, is it not? So this volume is in the numerator. So I will bring this to the denominator. This can be written as 3P divided by M by V. Okay, this is written as what? M by V. So this is mass by volume, that is equal to what? Density of the gas. So this is also equal to what? Square root of 3p divided by rho, which is the density of the gas. So all these formulae, if we remember, then we can solve some numerical problems. Okay. So how to write this in the examination? Suppose if they ask for 2 marks, no, first you write this expression, define RMS velocity. So this only is called as what? VRMS. From this, how to define RMS velocity of the gas molecules? It is defined as the square root of, first you have to start like that, it is defined as the square root of what? Square root of some average. Okay, so it is defined as the square root of the average value of, again, average value of what? The sum of the squares. Okay, so it is defined as the square root of the mean value or average value of the squares of the velocities of the gas molecules. That is only called as RMS velocity. So these are all the different ways by which we can express the RMS velocity. Now shall we solve one numerical problem in a very simple way? So in the competitive exam, such questions will definitely appear. So I will find out like this, calculate the RMS velocity, calculate the RMS velocity of oxygen gas, okay, oxygen gas at 27 degree Celsius. So the RMS velocity of oxygen gas at 27 degree Celsius. So let us consider for temperature 27 degrees Celsius. So first immediately we have to write 27 degrees Celsius is also equal to what? 27 plus 273 in Kelvin. So the temperature is now equal to what? 273 plus 27 is 300 K. And the universal gas constant is 8.31 joule per mole per Kelvin. Okay. Now the molecular mass of oxygen. So for oxygen, the molecular mass, see here, this is a 8O16, isn't it? So molecular is diatomic. Diatomic means 16 into 2 is 32 gram. 32 gram is the molar mass. So this is 2 into 16, that is equal to what? 32 gram. In kilogram, this is also equal to what? 32 into 10 power minus 3 kg per mole. Kilogram per mole. Okay, since it is diatomic, I have multiplied this mass number 16 by 2. So R, T, M, these are all available. Okay, we have to remember that the temperature must be in Kelvin. Now, which of these formula can be used here is R, T by M is here, isn't it? So, this formula I am going to use. So, VRMS is now equal to square root of 3RT by M. So, 3RT divided by molar mass. So, this is equal to square root of 3 into 8.31 multiplied by 300 divided by, this is a 32. So 32 into 10 power minus 3. Now after this you can follow whatever shortcuts in mathematics you are going to apply. See here 300, there are 2 zeros here. So I am going to remove these 2 decimals and write 3 into 831 into 3. So 3 3s are 9, is it not? So shortcuts. So I can write this 3 into 3 is 9 multiplied by 831 divided by 32, okay, into 10 power minus 3 is coming up as what? 10 power plus 3. So like that I can use some shortcuts also. Now I am going to use the calculator. Okay. So 9 into 831. 831 into 1000. So this is now equal to square root of 747.9 into 10 power 4. In this format I have taken, divided by 32. So 747.2 divided by 32. So this is coming as 20. So this is coming as 23.35. This ratio, this fraction is coming as 23.35 into square root of 10 power 4 can be taken as 10 power 2 outside the square root. So now I am going to find the value of square root of 23.35. So 23.35, if you take the square root, it is coming as 4.83. So this is 4.83 into 10 power 2. So if you multiply this, means this is equal to 483. Therefore VRMS is equal to 483 meters per second. So this is the RMS value of velocity, RMS velocity of oxygen gas at 27 degrees Celsius. I hope you must have understood this well. Fine.